Okay, I'm Toshio Suga, Professor of Physical Oceanography at Tohoku University. I'm also a visiting principal researcher at JAMSTEC, which had allowed me to be formally involved in the Argo program. I have been involved in Argo program since its inception, and I'm currently serving as a co-chair of International Argo Steering Team. Today, I am very grateful and honored to have the opportunity to introduce the history, structure, and the future of Argo as a background for discussion at this workshop, which is very important for the promotion of geochemical Argo. My talk is organized as the title suggests. First, I'd like to talk about the background and history of the Argo program. Then I'll talk about how Argo operates and how its data is used. Finally, I'll talk about the future of Argo and how we plan to develop it. At the end of the 20th century, the following questions were being posed to ocean science. How much heat is being and will be absorbed by the oceans due to global warming? And how are the oceans changing? How does or will a warming ocean affect climate and organisms on a global, regional, and local scale? However, the observations being conducted at the time were too sparse in time and space to adequately address these issues. This figure is an example of the distribution of ocean observation prior to the year 2000. It shows the distribution of stations that measured temperature from the sea surface to a depth of more than 700 meters during the month of January 1991, and is typical of the distribution at that time. There is noticeable spatial bias in the distribution of the observation points. There are large gaps in the middle of the oceans, especially in the southern hemisphere, where the data gaps extend. Meanwhile, by the mid-1990s, profiling float technology had become available. This is a picture of a typical profiling float and its internal structure. It floats and sinks autonomously by regulating its buoyancy by adding and subtracting oil to and from a bladder at the bottom. On the top, there are sensors for temperature and salinity and antenna for satellite communication. The float sinks to a predetermined depth, waits and drifts, then sinks to a further predetermined depth at the specified timing, and measures temperature and salinity while surfacing. When the float reaches the surface, it transmits the data to satellite, and the cycle repeats. The concept of Argo was born at the intersection of autonomous technology of profiling float and the scientific need for ocean observation to answer the question, what is the role of the ocean in the climate system? Argo was designed as a network more than 3,000 floats to measure temperature and salinity in the upper 2,000 meters of the global ocean, which means one float for every 3 by 3 degree in latitude and longitude. So, but I like to mention here, actually, I was not part of the group that formulated this plan, but I heard actually that there were quite a few people who were skeptical about whether it was really possible to build 3,000 float observation network. That's how unprecedented the challenge was. However, Argo's visions of real-time, high-quality observation of entire world's ocean and the immediate and unrestricted release of the data attracted many countries and the research and operational communities. The number of participating countries increased year by year, and around 2005, the global observation network was almost achieved, and in 2007, the target of 3,000 units was reached. And the array has continued to grow. This is the current status of Argo observing network. the global observation network has been maintained for more than 15 years. This has been made possible by close collaboration of many countries and continuous technology innovation. I would like to also to emphasize that Argo's innovative data management system provides unlimited access to real-time data for use in forecasting and other operations in each country, as well as high-quality data for research purpose. Again, both all real-time data and all high-quality delayed mode data are freely available to anybody. Argo has revolutionized ocean observation and has become a model for observation networks. Okay. To date, Argo has obtained over 2.4 million temperature salinity pressure profiles. This is notable in comparison to 0.5 million by research fleets in the entire history of oceanography. Let me explain a little more about how Argo is operated. The figure above shows the number of floats deployed per year, color-coded by country. And the number of floats deployed has remained almost constant since around 2005, with the exception of 2009, when there was a sensor recall, thanks to multinational cooperation. The average number of floats deployed during this period is about 880 per year. The Argo steering team coordinates the participating national programs. The national programs agree on common sampling protocols and priorities for global coverage, and put portion of their floats towards the global goal. The figure below shows the number of float operations, which has remained in the range of 3,800 to 4,000 units since around 2015. This includes pilots of enhanced or extended regional observations, such as near the western boundary currents, seasonal ice zone, and marginal seas. Now I'm touching on the innovative data management system that is the foundation of the Argo program. Okay. So the data observed by the floats are sent to the data assembly center operated by the major participating countries, where they are quality controlled in real time and fed in within 12 to 24 hours to operational centers around the world via GTS, and to other users via Global Data Assembly Center, GDACs, in the US and France. Delayed mode quality control is performed by the PI who put in the float or regional data experts, and high quality data for climate research is delivered through GDAC within 12 months. The Argo Regional Center are responsible for data accuracy monitoring and data product creation. Argo's comprehensive data management system is a model that has been widely adopted by other observing systems. Okay, moving on to the topic of how Argo data is being used. Since Argo has been implemented by research community, the most visible applications continue to be studies of climate variability and change. The figure on the right shows the time evolution of vertical distribution of temperature anomalies averaged over global oceans as captured by Argo. We now have a detailed picture of where and how much heat is accumulated in upper 2,000 meters of the global ocean. In addition, we can now obtain the same level of information on salinity as on temperature, which was previously overwhelmingly lacking compared to temperature. These data are making significant contribution to our understanding of the role of the ocean in the climate system. Argo data has been used in more than 4,400 scientific papers so far, with an increase of about 500 papers each year. One of the Argo's strengths in use is its suitability for integration with other observing systems. Argo's role as a subsurface ocean observing system with global coverage and 10-day time resolution makes it uniquely suited for system integration with satellite observation and in situ systems via data assimilation models and statistical analysis. The figure on the right is a time series of sea level budgets that exemplify this advantage. Change in sea level can now be monitored and understood as the sum of changes in ocean mass and changes in strict sea level. The integration of Argo, satellite-based altimetry and mass measurement, and tide gauges completes the sea level observing system. Many of Argo's applications in the commercial and government sectors are maintained indirectly through the forecasting community. The application area include agriculture, aquaculture, fisheries, oil and gas, emergency response, insurance, long-range coupled numerical weather prediction, national defense. The figure on the right shows how much temperature is in the operational model would change without Argo data. The color code is in degrees Celsius, so you can see that there is a big difference. By examining impact of various data on data assimilation model, Cummings and Smedstad stated, on the per observation basis, the most important global observing system is Argo. Now I'll talk about the future of Argo. The last decade has been the emergence of new demands on ocean data and new technology that can meet them. Profiling flow technology and CTD sensors for large depth have enabled deep Argo to sample variations in temperature, salinity, and ocean circulation from the surface to the bottom, thereby closing the regional and global budget of heat, freshwater, and sea level. New sensors such as oxygen, pH, nitrate, and chlorophyll that can be mounted on floats have enabled BGC Argo to sample biogeochemical variables and to address issues such as carbon cycle and ocean acidification, ocean deoxygenation, and marine resource management. Argo's discipline integrated full depth development is in line with recently launched GOOS 2030 strategy. The need for an integrated ocean observing system is also stated in the UN Decade of Ocean Science Implementation Plan, which seeks to contribute to the achievement of the Sustainable Development Goals through the transformative development of ocean science. Once again, there is an opportunity for Argo at the intersection of autonomous technology and scientific need. We believe that the encouraging end-user participation and leveraging Argo's unique ability to integrate across satellite and in situ measurement systems, Argo can play a central role in the next generation of ocean observing system. Okay, this is the new design of Argo called One Argo, which will build and operate an integrated observing network of 2,500 core floats in red, which means traditional 2,000-meter temperature salinity floats, and 1,200 deep floats in blue, and 1,000 BGC floats in green. This is fully in line with GOOS 2030 strategy, and Argo steering team has proposed One Argo as a program for the UN Decade of Ocean Science. Okay, this is the summary of my presentation. Recognizing global potential in the new technology of autonomous flowing float, the Argo program implemented an unprecedented subsurface ocean array of 4,000 floats. Argo floats are spread evenly and globally, with support and participation from more than 25 countries. The entire Argo dataset is freely available to anybody from GDAX. Argo data have been used in basic research, crime system assessment, education, and operational models for prediction and state estimate. One Argo, that is a global full-depth multidisciplinary array integrating core, BGC, and deep frauds, is proposed, which will serve society's needs for sustainable development, safety, well-being, and prosperity. Thank you for attention.